Hey, welcome back to Made Up of Wires, Decompiling Castlevania Symphony of the Night. I'm a little tired today. What we're going to do is finish off the castle gears. I mentioned several times that I believe these were separate files. Currently they're all in one single file, all the functions. For the PlayStation, that doesn't make a difference. For the PSP, it does, and for sharing the files between the PlayStation and the PSP versions of Symphony of the Night, we're going to have to split them into different files, one way or another, and so I think there's nothing to it but to do it. And if we get that done and all that's fine, then we'll work on getting the entity extension work finished for the gears. If we can reuse one entity extension for all the gears, great. If we can't, no harm, no foul. If you haven't watched the stream before, we're decompiling Castlevania Symphony of the Night. This is the Animos project. I'm a happy contributor. You can go to soten.z.dev to learn more. And let's get to it. So we're going to be working mostly in the terminal, not doing a lot of work in decomp.me, not working on matching. We matched all the functions already. We just need to get them into a form that makes them compatible with both systems, compilable, maintainable. So we're going to start, I think, with the PlayStation. That's what I usually like to do. And we'll go from there. So how do we want to do this? I've already kind of identified where the file splits should be. We're going to need to know a few things. Where are these offsets? In nz1.bin, which will be on your Symphony of the Night game disk if you're playing at home. And we need to figure out which of these files have global data that we need to reference and which don't. So I think finding the global data probably makes the most sense. Sideways gear large only references the things that are in the header, which are global to basically the entire stage or the game itself, as well as init environment. And init environment is also something that's relatively global, and I'm actually going to go and put that in the ND1 header. It's not something that is specific to this file at all, and it's used by a lot of files, so I think it does make sense to put in the stage header. I'd probably go a little bit further and say it's something that belongs to be in the global stage header, because it's something that is defined effectively for all of the stages. And we use that several different places in here, and so we're going to get rid of it, all the declarations, because those will no longer be necessary now that it's in the header file. And just to make sure that we're doing the right thing, we're going to build all, and going to do that every step along the way. So we don't have any data here. Our first data that we see linearly in this file comes at FB8. So let's look at the disassembled data, which will be in stnz1 data. And right now, this is just in a file called F44, and that's what we're going to be working on, is splitting this into its constituent parts. So here, this looks like something that's going to be part of E gear horizontal. And this data file is a generated file. It gets created by Splat. Any edits or changes that I make to this file will be destroyed next time the Splat config changes. So I want to just be careful here that I'm not putting anything too important. I just want notes, and I find them easier to place in line in the file, even though I know that it's ephemeral and will be destroyed. Oh yeah, I do want to look. So this FD8, which is used for the horizontal gear, is only used here. So I don't really have any risk of this being used elsewhere. And that's the only global that's used here. So most likely what comes next won't be here. So I'm going to jump to the end of this function. and look at the next one, which is this FC0. And like the other one, FC0 is also only used in this file. Or in this function. So again, I think that this is likely going to be specific to this file. Likewise, eGear small has its data. This one, so SPIM comes through. SPIM is the disassembler. It comes through and looks at the references that are in functions by interpreting how the MIPS instructions are generally build addresses in registers, and then it tries to split different sections of data into variables based on the use in code. Sometimes the way compilers work makes it obvious where variable boundaries are, other times it doesn't. And in this case, we have a .16, which is a struct with two 16-bit fields, and that's what gets generated, is a reference to this FC8 and a reference to FCA, and those references are baked into the generated code, just intermingled with everything else. And so when SPIM is coming through and sees that, it sees those two references, but it doesn't see anything to FCC or FCE because it's an array, and all the other subsequent offsets are added to these FCA and FC8 base addresses. And so we just need to be aware that it's not that we have a single 16-bit value here and then an array of 16-bit values. It's an array of 32-bit structs, which consist of two 16-bit values. And like that other one, I think this is the only function that uses this. And it is the only data. What is going on? Oh, do I have, yeah. Sometimes when you put if defs like this in place of Vim, it's confused. Now we have the wall gear puzzle, and I think that everything related to the wall gear puzzle, both the door and the gear itself, are going to be in one file, which is this wall gear file. It could be called whatever we want it to be called. That's what I'm going to call it for now. And that starts at FD0. And for my own sanity, I'm going to put these in order so that I can find them. There is this one, let's see, C1680. This looks like a, this looks like BSS. BSS is uninitialized data, which means that it's a global variable that isn't assigned to anything. Or if you're working with the MetroWorks compiler for the PSP, it's assigned to all zeros. And so I think that's what's going on here. Let's double check that. But I think this is BSS. And again, BSS is uninitialized data. Yeah, it is. So we'll have to note that as well. So I'm going to make a split here. Oh, interesting. It's already split into its own file. So this just needs to be renamed eval. So I think we have all the splits that we need. The next piece is we can do the splits actually two different ways. We can do the code first, or we could do the data first. There's no right or wrong way. Since we have the data already, let's do the data, and then we'll come back to the code, and we'll name the data all the right things, and then we'll split the code and name it all the right things. And I think then we'll be able to combine them, and that'll be the most straightforward way to do it. We could look at the PSP as well, but this has to be done regardless, so I'm gonna go with just the PlayStation for now, and hope that it works out and that I don't have to redo a bunch of work, but we'll see. So we want to find E gears down here. There already is RO data associated with it. We'll come back and figure out what that is in a little bit. And here's the C file, or the text, text being code. We're not going to do anything with that yet. What we need is to go to the F44 data section, figure out where our first set of data was, which is here at FB8, and we're going to add an entry to Splat to tell it at FB8 we have E gear horizontal, and this could be any name that we want. I'm calling it that. You want names that are memorable. At FC0. So the type, the second field, first field is the offset into the binary file that's on the disk. So this is nz1.bin. You can look it up on your own disk. It will be there. It'll be in the st directory, stnz1/nz1.bin. If you look at offset F44, there'll be a data section. We don't know what the data preceding this is yet. We'll figure that out eventually. If we put .data, the second field here is the type. .data means that data is going to be compiled into an object from a C file, and we want to get the data from that object. Data without the dot means it is coming from the disassembly. It doesn't exist in the C file yet, and so get it from the disassembly. And so we can name these sections whatever we want, but like I said, we want to make the names something memorable that will allow us and others to find this in the future. So FC0 is the next split, FC8, and these are all really small. Usually functions are, there's a bunch of functions in the same file. Maybe not, I don't know, well, maybe that's not the case. We treat them that way because it's usually easier to deal with. And then we have the wall gear. And let's speed that up. And we need to figure out where the end of E wall gear is. And I should have done a better job looking at that. Let's go back to the C file. So we have FD0 and FDC. So FEC is data that's just part of some other file. We don't know what it is, so we won't give it a name. And Splat will eventually end up generating a file called FEC. So then we know that there is already a BSS segment at 41680. So we're going to jump down there, and that is going to be our E wall gear file as well. And as long as each of these segments have the same name, basically we can eventually get to a C file that has all of them in it, and that's the goal. So we have this, and this should build. It's going to overwrite all my files, but that's fine. And when the data is coming from just disassembled data files like this, we don't have to worry about updating the C or worry about linkage or anything like that. It'll just work, and that's what it did. And so if we look at F44, now we've lost all of the data in there that was supposed to be with gears, and actually there will be a new E wall gear. There's a BSS file which has the data that we had before, and a data file that has the data for that one, and all of the other ones as well. All of the other let's see, gear. We have a bunch of different gear files. We have RO data, and let's look at what function is referring to that RO data. It's just going to be that one that has the debug section at the end. So as we split these, we have to remember which one that is so that we can get it in the right place. So let's do that next. So we're going to go to our, let's go to we have some matchings and some non-matchings. What's the best way to do this? Let's look at e-gears and see what's in the matchings. We'll start with horizontal, I guess. And 2824C, is that where our e-gears is already? No. So we know that that one is going to be 2824C. Basically, we need to go through each of these and create a new segment named the appropriate thing. And how did I name those? Called it gear. And I did mention that we do need to figure out the RO data. Let's do that quickly. Let's figure out which function it is that is going to be needing the RO data. Gear sideways small. What's the RO data in it? And so 2857C is where that's going to start. 2857C. These have to be in order. So the offset on the left has to be in order. And so we're going to call that E-gear sideways. E-gear. I think I just called it small. And this is the important part. We need to now move the RO data from E-gears to E-gear small. And we'll keep going. E-gear large, that 27FD4. And vertical is at 28354. And one more, which is going to be it's going to be in the non-matchings. It's wall gear. Well, I guess it might be in matchings. Two 8E4, and we'll call that E-wall gear. No, I'm going to change that. I'm going to call it E-gear puzzle. And that way they're all gear something. Okay, so we have 4 data segments, 5 C segments, and then an RO data segment and a BSS. And so now we have to do the fun thing of splitting these into multiple files, and it shouldn't be too bad. But we got to go through and do it. So I think I'm done with the splat config, and I don't think I'm going to need that. I do need to do all these other changes in the meantime, though. So I guess I could keep the splat config so that I have the names. Let's do that. Yeah. So I'm going to start with just E-gears. And often I'll do these kind of one at a time and update the splat config as I go. This time I'm going to do it a little bit differently. So first I'm going to do a git move for this, and I'm going to move this to eGear large. The eGears file needs to go away, and so instead of removing it, I'll just do a git move. And now we have that file. And I'll take out the comment here. Okay, next I need eGear roaming horizontal. And I'll do the split there. So when creating a new file, I don't need the license header. That will get generated automatically. I'm just going to take everything else, though, below here. And now our eGear large should be fine. And I don't need that one anymore. I'll leave it there for now, but I don't need it. And I will add this new gear horizontal file so I can forget it later on. eGear vertical. Same thing. I'm going to take the header and the copyright notice, grab everything at the tail of this other file, and then just kind of keep flipping back and forth like that until I get them all. One more. All right. So we have all the files. Our BSS up here, or sorry, our declarations up here are enough. I'm going to get rid of these declarations here. They shouldn't be necessary. So we have all of our files now. They've all been staged in Git. Just make sure that's true. And I think that's enough. So let's test that theory. And I think we should be fine. We're going to build those new files. Not building. We have an error. FDC is undeclared in Gear Puzzle. I got rid of that by accident. FDC. Is our 0.16? No, it's just S16. So I'll leave that there. That's specifically for the secret door. I like keeping the globals next to the functions that they're related to. Sometimes people put them all at the top. That's not my favorite style. All right, that worked. And all of these now are split into their own things. So now we can import the data. Yay! Who doesn't love importing data? And as we're doing that, let's start at the top. We'll go look at our data for the gears. And the goal here is to replace all these data segments here with .data segments. We're going to go to ASM US ST NZ1 data eGear horizontal. And down here in the C file, we're going to do the same thing. And these should be pretty easy. In this case, this is an animation. There's actually a better struct for animation. And I always forget what it is. So let me look at one of my recent changes. Let's see if this was the one. I'm really bad at remembering all the structs. Animation frame? I think it is. Let's look. Yes. All right, so let's go find animation frame and see what that looks like. I'm gonna copy this data in. Let's just split again. It'll be unreadable, but that's okay. Interesting. So this is two unsigned 16s, which I guess is fine. So we're going to change this to an animation frame array. Now we make it static so that it doesn't have external visibility. And we have to remember that these are little endian. I think that's, in my opinion, the biggest mistake of the PlayStation architecture is being little endian. Biggest mistake. I just have no interest in little endian anything. This seems odd to me, but the way structs in C are defined basically are the same as arrays. I think that's it. That looks strange. Anyway, let's see if I got it correct. So we're going to change data to .data and try building again. I will resplit. We'll rebuild everything, and then, yeah, that's all it was. So let's move on to gear vertical. Looks like we basically have the same thing. Are these the same? 0408, 0508, 0608, and 0000. Looks good to me. Another one bites the dust. Okay, small. Okay, now we're going to do the same thing. And then E-Gear puzzle is going to be slightly different, but mostly the same. We have BSS that we have to worry about. Let's open it down here. So we have 4 assigned 16s. That's all we need to do. We'll make it static. So nothing more there. Go down to the big and mark this as a .bss. And then for our data, FD0 is just a sine32. The critical thing here is it's initialized to 0, but it actually is set to a value, which makes it show up in data. Functionally, there would be no difference from a logic perspective to leave this uninitialized, and see uninitialized globals are automatically set to 0. So we have that guarantee, but we know because it's in the data segment as opposed to the BSS segment that it's explicitly set to 0 here. I don't know if that's terribly important to know, but that is what is happening. I think it's best to just type these. And then FDC. FDC is a little longer. Make sure all these are static and not extern. Oops. When you do vertical, like columnar visual mode in Vim, it doesn't produce the lines when you paste. It just overwrites everything in the vertical space. Make sure I don't have any more externs. I don't. So we can do the your puzzle as well. That's it. Let's see if this builds. Perfect. I'm gonna commit all of this. At least stage it. All right. So now we get the fun of doing the same thing for the PSP. And what's a little nicer about the PSP is we've already done all the work on the PlayStation and we know that it's correct. Let me do one more thing in eGear small. We don't want this code here. We want to get it from pad 2 anim debug. And that will ensure that this is already PSP safe. And gets rid of the if-defs in this file. All right. So let's go get the PSP STNZ1. And now, so this is gonna be a little different. We know that this is out of order, and so when we're splitting this up into different files, we need to make sure that they're in the order that the PSP has them in, as opposed to the order that they show up in the PlayStation. And we'll just get that from the order that they show up in the PlayStation's or PSP's eGears file, NZ1 PSP eGears. But we need to, all these files now have the data in them already, so we need to be aware of that and make sure that we're mapping the data at the same time. So we kind of have to do two things at the same time. I am going to go look for example, the wall gear data. And so we know what this data looks like in all the files, and I'm assuming that it is going to be the same data. So we can leverage that knowledge to arrange this the same way. So let's open up STNZ1 E wall gear, E gear puzzle. That's what I named it. And here we start with the 200, 300, 200, 800, 300, E100, and then later on have basically all this data down through here. So this is the end of the gear puzzle. And it starts up here. So we're in 49810. 49810. So we'll make our data segments. And these are going to be .data right away because I'm just going to use the PlayStation files. So this is going to come from NZ1 E here puzzle, and it's going to go through 498DO. And we don't know what this is yet, so we'll just leave it like that. So next, secret door is part of that same thing. We don't have to worry about that. Gear sideways large doesn't have any data. Next one is E gear vertical. That has this data at F68. And this is kind of nice. It ends this file 498E8. And that's going to be .data, and that's going to be at NZ1 E gear vertical. And I don't have the other two in here, so we have sideways small, and the other one. All right, so this is where things are going to diverge slightly. On the PS1, when you have strings like the charl that gets printed in the debug information, those strings go into the RO data segment along with jump tables. On the PSP, compiled by MetroWorks, it puts that text, those strings, into the data segment. So we're going to have two, or we're going to have an extra piece of data here that doesn't exist on the PlayStation data segment, but when we compile it from the same C file, everything will work out just fine. So we want to look for this F8, 17, 27, etc. We want to look for those and see where those are, and then see where that string is as well. So 00F8 is what I'm going to be looking for. It should be around here somewhere, and here it is, 498DO, and I think we actually already have that. And that takes us to 49E8E. So that's everything related to this. So that's going to be R and Z1 E here small, and we're missing large. Large doesn't have any files. Vertical? Horizontal. So we need the horizontal. Horizontal has the same data in it that small does. And so we should see before gear puzzle the 0408 and 0508. So let's hope that that is what we see. Oh, I missed one. 498E8. Oh no, sorry. Yes, here's our 0508 and 0408. So 498EO is where NZ1E gear horizontal. So I think if I remember correctly, one of the theories about how all of like the tooling works for the PSP is it took these files, ordered them alphabetically, and then compiled them. And obviously we don't know what the names are for the files. There's no metadata in any of the binaries that tell us what those names are. So we just have to guess. And in this case, we have horizontal, puzzle, small, vertical. Hey, that just happens to be alphabetical order. Wasn't planned, just luck. So now we need to go back up to E gears, excuse me. And we need to split this file as well. And this is going to end up being in the same order as down here. I'm going to grab all 4 of these. There's actually going to be 5 of them up here, but we'll take it. There is no RO data on the PSP, which is nice. So let's look at the order from PlayStation. Sorry, not the order. I just want to get the set of... We don't want to get anything from the PlayStation. We want to look at the order that is in the C file for the PSP. So we have horizontal coming first, the puzzle next, so this this breaks my alphabetical theory. We have large, small, vertical. It only breaks the theory because of the way I name these. It has nothing to do with anything else. So the next part of this, so we get rid of, we know that E gear horizontal is going to be at this 23828. Gotta get the offsets for all of these other ones. That's the hard part about splitting files, or the part that I like the least. So ASM, PSP, EU, ST, NZ1. Let's try non-matchings and see if it shows up there. I don't know if they're all going to be in non-matchings. E gears. And we're going to start with the entity wall gear. Need that one first. And is that one in matches? I guess it's matching. It's going to start at 23958. And we can get vertical while we're here. 2470. Go back to non-matchings. And we need large. And small. And these need to all be C files as opposed to data. And we're going to use the same C files that we had before. We do need to get rid of gears. And if I did everything right, which I'm sure I didn't, but if I did everything right, this should compile just fine using the files that are in. I did it right. Using the files that were in the PlayStation directory. So now we just have one set of code and it's being used for everything, and we can get RM, the PSP specific E gears file. That went so smooth. And that helps us now reduce the amount of PSP specific code. Everything is shared between the two versions of the game. And there's pretty limited difference, if I remember correctly, but that's what it is. So let's get all that in the working set as well. Not much to do, just some splat config. All right, so now we have our 5 gear-related files. We don't have to worry about splat anymore. Let's start at the top and just do a quick review of these and see if there's anything that I would want to do. We're doing fine. Let's do a fast format. This will go through and you can see all the things that I didn't want to do manually that it did for me. This is like cargo fix, except it works. It wasn't, maybe it was or was not cargo fix's fault. I've been doing a bunch of Rust. Still not my favorite language. I understand some of the appeal. I mean, maybe if you're a C++ programmer, it's a better language, but I think that that's about the only language that it might be better than. And so there's a bunch of nice like built-in linting and tooling in Cargo. But one of the things that I feel like the Symphony of the Night decompilation project has done a good job in is in our linters, in our like fixer-uppers, it never breaks your build. And a bunch of work has gone into basically making it so that we're not going to break anything. We don't stash like the current working directory and make sure that it's guaranteed to not be broken, but the way things are written, they err on the side of safety. I had several times where cargo fix fixed my code by making it uncompilable. That seems very broken. Like I understand why it made the changes that it did, and I understand what the errors are that I made. But tooling that's supposed to help you, especially people new to the language, should never end up with your code being broken at the end. All right, so we fixed it up and everything is looking good. So we have get player collision, has a bunch of magic values in it. Not my favorite necessarily, but that is okay. These fixed values here we can actually change to fix. That's probably something that I should add a lint for. Just make sure that this is fine. So when we build these files now and run build all, it's going to be rebuilt for the PlayStation and the PSP because they're being used in both places. And that's one of the advantages to build all is in the past when this would happen, you'd run make and it would run whatever version you had set in your environment. And you might be breaking another version of the game. That sucks. In this case, we know that we're not. Let's do this. Let's look at... Hey, Ansh. Good to have you. I thought collision had flags. I guess not. I wonder if they... No, I don't think they are. I was going to say, I wonder if they are the same as the collider flags, but it doesn't look like they are. Anything else that I would... Let's fix these other fixed... Thank you very much. Ansh says, my channel name's so cool. Do you know the reference? I like how kind of ambiguous the reference is, but also like that when people who are in the know understand the reference as well. right, so I think that's good for eGear horizontal. If there's things in here that people think should be changed, or they don't like the way that I've formatted something, keep it to yourself. No, I'm kidding. Tell me, because I'd rather fix it before sending out for PR. Let's see. Oh, you don't know the reference. How much jank or weird code, R6 says, how much jank or weird code have you run into when decompiling this? All the jank, all the weird code. So it was said pretty eloquently by Biz Murphy. There's people who can definitely put this into words much better than myself. And he made the comment in Discord, which go to soten.z.dev and you can find the Discord, join us there, that the developers who were working on this had just come from, this was 1996-97 where the development was being done. PlayStation was, I think, 95, right? Prior to the PlayStation, the majority of game developers were developing in assembly. And so you have a bunch of assembly programmers who are coming in and now mostly being forced to write in C. The PlayStation really didn't have support for writing assembly. You could write assembly directly because the compiler supported it, but Sony's stance basically was, here's our C libraries, use the C libraries. So you had these assembly programmers come in who were writing extremely terse C, extremely dense C, packing things into arrays of, some size, but then using, instead of it being, say, an array of signed 16 values, they would use it just as an array of whatever they wanted and, just treat it as a bag of bytes, basically. So while this game did come out a few years later, I know like Iga, for example, he had come from Rondo Blood, which would have been PC Engine, and that would have all been done in assembly. As far as I know, there was some tools for writing C for like Sega CD, maybe the Genesis, but really most of the systems were just done in assembly prior to the PlayStation. The Saturn, I know there were C tools for that, and so it's possible that the Saturn, maybe the 32X, had shipped C compilers before that. So anyway, I think there's just a lot of oh yeah, Tokamaki Memorial, yeah. There's just a lot of like assembly-isms throughout, as well as just the difference between, I think, Western and Eastern style programming. There's a bunch of that as well. So what I want to do is see if I can consolidate the entity extension here. So I created a gear puzzle extension. Every time we muck with this, so we do have a cooldown timer we can use here. Every time we muck with this, we have to recompile basically the entire game. So we want to be very careful with how much we do anything in this entity.h file, and kind of do so surgically. So I'm going to look for all the cases that I can get rid of that are using this illegal field in the union, get rid of as many of those as possible first. So anything that's going into offset 2 here, we should be able to use the cooldown timer I probably will just end up renaming that to timer, but again, not until I've made sure of it everywhere. And I probably will have to rename gear puzzle field to just gear. There's a bunch of things too where there are I talked about this quite a while ago, but like they'll build little scripting languages in the game. Completely bizarre. Like nobody builds little scripting languages for their program, but Konami does. So the way that the clock tower is rendered, the 3D clock tower when you're in Castle Keep, there is a little script that goes through to generate all those polygons, and a little interpreter for that script. And there's actually two different languages, one to draw triangles, one to draw squares, polygon or quads. Okay, so that might be most of the twos. Any other U16 offset twos? It doesn't look like it. So then at E-gear large, so we want to look at between large, small, and vertical, where we still have entity extensions left. Are we using all the same offsets, and are they being used for the same things? So at 7C plus 8 bytes, we have it being assigned to a collision. We're checking what looks like a collision enumeration there. Collision, collision, collision. So that's likely a collision. So I think we're going to go through and add that field at offset 8. So that's going to be at 8.4 in the entity struct. And we have an unsigned 8 there, and we'll call it collision. So now everywhere we have ext illegal U8 8 ext gear puzzle collision. And we have to do that in vertical, we have to do it in small. And anywhere else? And large. And now we'll have to rebuild about 2,000 files. But nothing to it but to do it. Oh, the Tohu bullet hell pattern, or scripting language. That's interesting. I think people basically were less shy. About doing things like that. So all this built fine. We get a bunch of errors and warnings from other things that are unrelated to these changes. So not too concerned about that. So let's find the next one. So when we see offset 8, offset 9, again, we want to check, are these being used for the same things? And are they being used consistently? We have offset 3 for the unsigned 16s. All of these unsigned 16s, signed 16s, everything that's in illegal is a union. If you're not familiar with unions, they're a little different from other languages. Actually, enums in Rust are actually extremely similar to how unions work in C. Has the inverted castle been started? There's Medusa from the inverted castle has been decompiled, and I did the reverse castle keep when I did the castle keep because they were both small and similar, but most of the reverse castle has not been started. Reverse warp room, that's done. So I'm gonna grab, I think I'm just gonna grab all this. And what I want to do is grab all the use of each of these, sort them, and then kind of do the same thing. And then I think we'll be able to, I think there's 3 more fields that we're going to need. D2XDD2 says, C Quake was a language written for Quake, and a lot of people learn that as their first language. That's cool as well. The fact that like a proprietary internal language was so well known that it could be used like that. Usually what happens with languages that are kind of one-offs and internal like that is that they are so obscure that they never really get much support. All right, so we have offset 3, which is a timer. I think I'm going to end up calling the cooldown timer. So I'll call this one just timer 2. Not creative, but that's okay. We have offset 8 in the 16-bit space being set but never read. That's exciting. And then offset 9 looks like it's offset Y. I'll call 8 offset X just to keep it consistent. My guess is that it probably is like a pair like that. So let's start with 3. We have a space already for the third index 16-bit value, which would be the 4th in that array. I'm just going to call it timer 2. And I'll do the same search and replace that I did earlier. I have some places that I'm referring to it as an unsigned 16 and some as a signed, which is not the best, but that's what I did. I'm going to call that timer 2. Let's see where that was. Set 3 was in vertical. Looks like it's all in vertical. Looks like this might be maybe, I was gonna say maybe it's a timer for going up and down, but I'm not convinced of that. Name first. Figure out what it does later. I should compile this now, but I'm not going to. So we're going to, at 85, we're going to pad this by 24 bits to make this around 32 bits. So we have 4 16-bit values, 2, 4, 6. So this would be the same as offset 2, offset 4, and offset 6. So we have another unused 32-bit space here. And then at 8C, we're going to have 2 sine 16s, and we'll call that offset X and offset Y. And I will build this now. So we'll take the hit of building everything, but assuming I have all those offsets correct, we won't have to do this again, and I can go fix up the other files and we can be done. Oh, back to the name. The Made Up of Wires channel name comes from a Nine Inch Nails song called The Becoming. For a decompilation channel, though, most of these games are string, glue, wires, whatever you need. That's all building fine. So let's get these other ones. So unsigned 16, 9. That's going to be offset Y. And where are these? Angle's probably a better name for this. I might change it later. Yeah, R6 says senior staff was likely unfamiliar with C because before that, game programming revolved around 68K, Z80, 6502. Absolutely. And if my professional experience is any indicator of what management was like, you're kind of worried. You know that your devs are productive in these languages and tools, and trying to move on to something new could be extremely productive. And in this case, I would say C is significantly more productive than assembly. But you don't know, and it's unknown, so you don't want to necessarily push that on everybody. I was fortunate enough to entity needs merge. Ooh, I might be in the middle of a rebase, which could be bad. All right, is that it? We're building clean. Let's run a format again. See how things are doing. So we're getting yelled at. This is a new lint that I added recently. It's saying create entity failed because I used a constant when I should be using an enum. And I agree. Let's go find the correct enum for create entity. It is 6. And I don't like this. The standard for how we used to write these was to have the value in a comment to the left and a block comment, and now we don't have that anymore. So I have to count. 1, 2, 3, 4. Intense explosion is what I'm going to go with. Is that right? The other one is explosion, number 2. It makes sense that that would be explosion. There's an intense explosion there as well. Intense explosion. I would have written the linter to make these changes for you, but there's a little bit of a issue with that. It's an e-breakable bridge. And the issue is when we're running linters only have the context of the line that the linter is evaluating. And so you don't necessarily even know what file that line is coming from. If we knew more about what that file is, we could look at the header, grab the enum, and then replace it. But unfortunately, there isn't that much context. Run the formatter again. Well, that's some lovely code. This is related to the breakable bridge stuff that was done last week. I think that's it though. That's we have all the gears. All the gears are done. Breakable bridge is done. You just get all this merged. And there's nothing more to do. We did it. There's obviously a lot more to do. How much is left? We'll look at all the include ASMs in NZ1. 65 left. Karasuman probably would be relatively fun to do. Is there fleet armor? I think I did already because I wanted to see how it was different from the library fleet armor. There's some odd things here, E-Fleeman. The fact that that's not matching with other Fleemen is a little strange. And then obviously some of the new stuff that's exclusive to the clock tower. So the clock tower is being done. ARE, what is ARE? You can go to soten.fun. That's a wiki that has some stuff about the game. And go to stage, and it'll tell you what all the stages are. And when I forget, that's where I go. Coliseum. So we don't have Coliseum, as far as I know, hasn't been started. That's the only stage left in the upright castle, the first castle that hasn't been started. And like I said, with the exception of our top, nothing else has been. I could maybe update this and mark that, but we should have it. Our success, so much code for Karsuman only to get stunned indefinitely. Truth. Very much truth. Oh, I'm not showing you the page that I'm at. Soten.fun. Lots of a minimal amount of information. Like every wiki that is started with good intentions. Just enough information for it to be valuable, but not enough for it to be complete. Go there though, and help add to it. That's all I'm gonna do today. I got lots of stuff to do. Have some fights to fight, some fires to put out, and some, I don't know, housework to attend to. If this would load, you could go to soten.z.dev and see our progress, as well as get a link to GitHub and Discord. It's soten.z.dev's fault. It's my computer's fault and the way that I use my computer. So apologies for that, but imagine some graphs. We can go to, we'll go look at GitHub instead. Nope, can't even do that. Can't even do that right. Oh well. Adios. See y'all on Monday.